Why does the sphere volume formula work? Imagine trying to fill a perfectly round ball with water. How much space does that water take up? That's what the sphere volume formula helps us figure out. It tells us exactly how much room is inside a sphere. But why does that formula work? Let's find out together. First, think about what volume means. It's the amount of space an object takes up. For simple shapes like boxes or cylinders, we find volume by multiplying area by height. But a sphere is different because its shape curves all around. The cross-section of a sphere changes as you move from the top to the bottom. To understand how the formula works, picture slicing the sphere into many tiny, flat disks. These disks are stacked from the top to the bottom. Each one has a small radius that depends on where it is in the sphere. The area of each disk is calculated by multiplying pi by the radius squared. The trick is to add up all these tiny disks' volumes. This process is called integration. It's a way to sum up an infinite number of tiny slices to get the total volume. The radius of each disk relates to its height using the Pythagorean theorem. Basically, the radius squared plus the height squared equals the sphere's radius squared. This relationship helps us set up the math. When we perform the integration, it simplifies to the formula of for divided by 3 times pi times the radius cubed. This shows that the volume depends on the cube of the radius because volume is a three-dimensional measure. The pi appears because the slices are circles, and circles involve pi. Archimedes, a famous mathematician, also helped explain why this formula makes sense. He found that if you compare a sphere to a cylinder with the same radius and height, the sphere's volume is exactly 2/3 of the cylinder's volume. This relationship confirms the formula because the volume of a cylinder is pi times the radius squared times the height. The 4/3 factor in the formula comes from the shape's curved surface. It accounts for how the sphere's volume is less than a simple cube or cylinder of the same size. Doubling the radius makes the volume grow 8 times larger because of the cube relationship. And the pi is there because all the cross-sections are circles. Knowing the volume of a sphere is useful in many real-world situations. For example, scientists use it to calculate the space inside planets or bubbles. Engineers use it to design spherical tanks. Even when you play with balls or globes, understanding how much space they take up is based on this formula. So, the reason the sphere volume formula works is because it sums up the tiny circular slices that make up the sphere. Using calculus and geometric relationships, it captures the total space inside perfectly. The formula, for divided by 3 times pi times the radius cubed, is a compact way to describe that total space. It combines the shape's roundness, the way circles work, and the three-dimensional growth of volume.